We're going to start learning factoring. And factoring is one of the most important skills that you learn in Algebra 1 because it's something that you will do in literally every other math class you take, with the possible exception of statistics. But geometry, algebra 2, pre-calc, calculus, pretty much every one of those traditional math classes you will use factoring. So it's really, really important, and it does take a little while to get the hang of it. Once you learn factoring, it's not bad. Some people find it to be really fun, especially if you're good with those prime factors. It can be kind of fun, like a puzzle to figure out. But even if you don't find it fun, it is one of those things that you have to learn how to do if you want to survive the next few years of math. So you've done factoring before. In fact, you've heard the word factor back whenever you learned fractions, and we talked about the greatest common factor or greatest common denominator. So you're familiar with the word factor. When we say we're going to factor something, what we mean is that we're going to divide it. So for example, if we look at this first problem here, 15x and 25x squared, let's look just at the number 15. If I asked you to just factor 15, what I mean is, what are two numbers I can multiply together to get 15? Well, there's two kind of silly numbers we could use, and that's 1 and 15. 1 times 15 is 15. I say that's silly because we still have 15 in the factor. So the best factor of 15 is 3 and 5. So 3 times 5 is 15. So that's called factoring 15. Now this is not 15, this is 15x. So to get 15x, it's actually 3 times 5 times x. So 15x is 3 times 5 times x. Let's do the same thing for 25. In this case, it's 25x squared, but let's focus just on the 25. Let's go ahead and factor 25. So 25 is 5 times 5. Okay, so we're going to do 5 times 5. But this is 25x squared. And what is x squared? Well, we factor x squared. That's pretty simple. X squared is just x times x. That's what squared means. It means something multiplied by itself. So x squared means times x times x. So we have now factored 15x, and we have factored 25x squared. Now, in order to factor this entire thing, this entire binomial here, 15x plus 25x squared, what we're looking for is something called the greatest common factor, which is something you have done before. You've done greatest common factor before. You haven't done it with variables before, probably, but you've done it just with numbers. So to find the greatest common factor, what we do is we look at these two lists that we've created, these lists of factors. And what I'm looking for is what factors appear in both of these lists. And that's easy enough. If I look at both of these lists, I can see, first of all, that there is a 5 in both of these lists. So 5 is a common factor of 15x and 25x squared. 5 is a common factor. What else is a common factor? Well, both of these have an x. So x is also a common factor. The greatest common factor, which we will abbreviate as GCF, the greatest common factor, is both the 5 and the x together, 5 times x, which we will just write as 5x. So the greatest common factor of 15x and 25x squared is 5x. So what we're factoring is this entire binomial, 15x plus 25x squared, meaning I want to come up with two things that I can multiply together to get 15x plus 25x squared. What two things can I multiply together to get this? And the greatest common factor is one of those two things. 5x is one of the two things that I multiply together to get 15x plus 25x squared. 5x times something gives me that. What's the something? Okay, So here's how we write this. We're going to do 5x, and then we're going to do a set of parentheses. And inside the parentheses, there are going to be two things separated by a plus sign. How do I know there are going to be two things separated by a plus sign? Because the problem was two things separated by a plus sign. The problem had two terms with a plus sign in the middle, so the parentheses are going to have two terms with a plus sign in the middle. Think of factoring in this case as being like the distributive property in reverse. I'm trying to set up a distributive property problem so that after I do the distributive property, I get 15x plus 25x squared. So 5x multiplied by what? 5x times what would give me that 15x that I had in the original problem. 5x times what is 15x? And some of you are like screaming, I know what it is. I have the answer. I know what it is. But let's say that I don't know what the answer is. I can't figure it out. 5x, I have no idea. I can figure it out by dividing. What is 15x divided by 5x? And we know how to do this. 15 divided by 5 is 3, and x divided by x cancels, so the answer is just 3. 5x times 3 is 15x. So 3 goes in that first blank right there. Okay, what would go in the second blank? 5x times what would give me 25x squared? And again, if I don't know just by looking, I can divide. What's 25x squared divided by 5x? Oops, probably don't need a ruler for this. So 25 divided by 5 is 5. And x squared divided by x is x. And I can check and make sure I'm right by asking myself, is 5x times 5x equal to 25x squared? Yes, it is. So the answer to this problem is 5, whoops, that's gross, 5x, and in parentheses, 3 plus 5x. This is my answer. And I can check my answer by doing the distributive property. 5x times 3 is 15x, and 5x times 5x is 25x squared. I have now factored 15x plus 25x squared. So this is factoring with just two terms. Let's move on to this problem and factor with three terms. Okay, so again, I'm going to start off by figuring out the factors of 12x, y. Well, 12 is 3 times 4. Oh, but 4 can actually be factored again. 4 is not a prime number. 4 is 2 times 2. So instead of 3 times 4, I'm going to do 3 times 2 times 2, and then it's xy, so times x times y. There we go. And then 24xy squared. I'm going to do 24xy squared. 24 is, let's say 6 times 4. 6 times 4. Oh, but 6 is 3 times 2. So let's replace this 6 with 3 times 2. And 4 is 2 times 2. So 24 is actually 3 times 2 times 2 times 2. And then times x, and then times y squared. Y squared is y times y. And then last we've got 30 x squared y to the fourth. 30 is 5 times 6. Oh, but 6 is not a prime number. 6 is 3 times 2. So let's replace this 6 with 3 times 2. And then times x squared, which is x times x. And then times y to the fourth, which is y times y times y times y. Okay, so now that we've got our factored list done, what we want to look for is, what do these lists have in common? Okay, what do they all have? Well, they've all got a 3. There we go. They've all got a 2. They all have an x. and they all have a y. That's all they have in common, 3, 2, x, y. So the greatest common factor, or the GCF, is 3 times 2 times x times y, which is 6xy. So when I factor this, I'm looking for two things that I can multiply together to get these three terms, and one of those two things is 6xy. So 6xy is going to be outside my parentheses. Inside my parentheses, I'm going to have three terms separated by a plus and then a minus. How do I know that? Because my problem was three terms separated by a plus and then a minus. So the parentheses are also going to be three terms separated by a plus and then a minus. Okay. So the thing that goes in this first blank right here is whatever I need to multiply 6xy by in order to get 12. Now in the previous problem, I told you you could divide 12xy divided by 6xy, but you could also just go look at your factor list. What was left in my factor list? 2. Okay, the thing that goes here is 6xy times what would give me 24xy squared. Again, I could do 24xy squared divided by 6xy, like we did in the first problem, or we could look at what's left in our factor list. 2 times 2 times y. 2 times 2 times y is 4y. And then same thing for this last term. 6xy times what is 30x squared y to the fourth. We could do 30x squared y to the fourth divided by 6xy, or we could look at our factor list. 5x, 1, 2, 3 y's. So 5x y to the third power. And there's our answer. The two things that we multiply together to get that original polynomial is 6xy times the quantity 2 plus 4y minus 5xy cubed. And that is how we factor using the distributive property.